Oh. Can you hear my voice? Can you check it and tell me? Okay, wait. Again, I will unplug it and plug it. Wait. Now can you hear?
Yes, ma'am.
Okay, fine. Shall we start?
Yes,
ma'am. Okay, fine. How many people are there? Hello?
Wait, ma'am. 10, ma'am. 8, ma'am, including you and the admin.
Very good answer.
Today.
Very good. We'll wait for 1 or 2 minutes.
Okay,
No one join, we'll start.
Okay, ma'am.
Okay. Already I have started. I'm waiting for you people one by one, you all join. So last lesson is useful for you people. Do you feel like that? Did you learn something? Hello?
Hello.
Yes, yes. Could you hear me well?
Yeah. Yeah, ma'am.
Okay. How many of you are there in class?
13 participants are there, ma'am.
11 people, ma'am.
Shall we start or will wait? It's up to you people.
Let's start, ma'am.
Every minute one person is coming, ma'am.
Okay, then we'll start. Anyhow, we told the time already, no? No need to wait.
Yes, ma'am.
Okay. Actually, we have seen, what are the things we have seen from yesterday's class? We have seen what are the water sources and how, once you find out the water source, how to convey.
Ma'am, sorry, ma'am. Which topic we are doing right now?
I will tell you, ma'am, everything is secretive. Please hear me properly. Then only thrilling will be there. Hello?
Hello?
You didn't hear
voice is getting broken.
Okay, okay. Ma'am, I told you that you please listen me. I will tell you. Then only the real thrill will be there in class.
Okay.
Did you hear me?
Yes, ma'am. I was checking some unit, which unit we are doing, that's all.
No, don't look at that. Please hear me, I said.
Sure, ma'am, please.
Okay. We have seen in this paper, right from starting, what are the water sources available for public water supply. Then once you identify the source, you have to take the water from the source, how to take. Then once you take out the water from the source, you have to convey the water, how to convey we have seen. While conveying, what are the things you have to consider, we have discussed. While conveying, what are the problem will come, that is in terms of corrosion and tuberculosis, we have checked. Then we have seen what are the qualities of water. Now we are going to see treatment of water. Why we have to do the treatment? Why have to treat the water?
Water is not fit for use. To make it for use, we need to treat.
Okay, fine. Okay, fine. Anyhow, you have done the test by analysis of while finding out the resource. That time itself, you would have assessed some studies that water source is, a particular source is suitable for public water supply or not. That is in terms of quality, in terms of quantity, and in terms of economic and technical feasibility. All the assessment you made, then only you have decided, okay, this water source, either it is Manjira or Godavari or Krishna, we can take water for Hyderabad water supply. You decide, isn't it?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah,
So you
yeah.
have done all the studies, and then you have done the quality study also, physical, chemical, biological characteristics, how it is not, then it can be used or not, you would have decided there itself. Next stage of testing. But further, we wanted to do treatment. Why? What is the reason behind that? Whatever you have answered, that is correct. So water is not suitable or unfit for water. To make it fit, you have to do the treatment. That is correct. If you unfit a thing, why you have done this much long study? Then you wanted to make it fit means what? What would be the reason behind that? Do you get my point? No, no one is getting my point?
No, ma'am.
Ma'am, please say again, ma'am. Repeat again.
I said, what you have seen in last class?
Water treatment and physical and
No,
chemical,
I didn't mention the term water treatment. I said water
physical and
characterization.
what characterization, physical
Yes,
and
ma'am.
chemical.
Characters of water. Yes. Characters of water like color, taste, texture, hardness or soft.
Okay, that is not texture, ma'am. That is chemical constituents.
Yeah, sorry, ma'am.
Okay. we have studied physical, chemical, and biological characteristics of water. After finding out the source of water, we have to assess it, how far it is. Anyhow, when we have decided the water source, that time itself decided it could be used for human consumption. But further, in terms of health aspect, we have to consider physical, chemical, and biological characteristics. If one or two characteristics are more or less when compared to all the characteristics, those characteristics we have to bring down into the level or bring down into the standard. For that, we need to do treatment. Understood? Hello?
Yeah,
Hello?
Yes,
Understood?
ma'am.
Okay, fine. So, because while the treatment stage and the kind of treatment what we are going to follow, which depends upon the characteristics of water. The characteristics of water due to the season, due to the rainfall and the other impact, that characteristics will be little changed. This month or this week water quality, if you would have done, means next month, next week, the same characteristics will be there. We cannot expect, because there will be a lot of animal would have died, a lot of human being would have died, and that whatever the animals and the plants and these wastes will be dumped into the water. They may do, they may not do, and the rainfall may be affected the quantity and the quality of water. And if it does not rain also, that also makes the change in rainwater characteristics. So the rainwater quality will be keep on changing from any source. Some of the characters may be standard or fixed, or we can say it is normal, or it will not be fluctuate. Until or otherwise, the characteristics of water from any source will be changed. With changes depends upon the season, activities in the local area, and also the rainfall level. Do you understand? Okay. Then here what we are going to see in this particular lesson, what are the stages of treatment is available, not we are giving. Stages of treatment is available for drinking water. In general, this treatment generally people are giving for what Madam said is correct, that is to make the unsuitable water for suitable to drink. For that, some of the treatment is essential. The essential or the objectives of doing the treatment is for removal of unpleasant taste, smell, and odor, removal of pathogenic bacteria, removal of turbidity and suspended impurities, for regulating the pH value within the desirable limits. Please underline the sentence. And also for removing hardness. For this purpose, we need to do the treatment process for commercial water or public water supply. Did you get my points?
Yes, ma'am.
Okay.
Yes, ma'am.
And there are general 3 important stages of treatment is available in general. That is sedimentation or settling process with and without chemical, that is called coagulation. Second important stage of treatment is called filtration. And the third important stage of treatment is called chlorination or disinfection. But anyhow, some of the auxiliary methods are available for the water treatment, which is based on the characteristics of water. That is aeration, softening, pre-chlorination, and activated carbon treatment. Now, you people please stay there itself. I'll come to the board. I will explain from there. Okay. Wait for 1 minute. Let me get ready. 1 minute. Please be online.
Okay, ma'am.
Can you see the board? Please tell me.
Yes, ma'am. Lovely.
Okay.
Ma'am, you need to adjust the camera.
Yes, ma'am. Perfect, ma'am. You're talking? I'm not able to hear.
Can you?
Yes, ma'am. Ma'am? No, ma'am. Again, we can't.
Ma'am, your voice,
What is the event?
your voice is not coming.
My voice. Now,
Ma'am, you can remove your earphones and put it on speaker. Maybe then we can hear you properly when it's far also.
let me do that also. Now it is coming. It will not.
Yes, ma'am. Ma'am can't hear you if you're talking.
Ma'am, it's not audible, ma'am. Your voice. Madam, voice is not coming.
Ma'am, you are visible but not audible. Ma'am, still now you are not audible, ma'am.
Wait. Now can you hear me? Please tell me, respond to me. Hello. 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 Now for me, no need. I know that without seeing that also I can explain. But for you people, okay, fine.
Okay, ma'am.
Huh? Okay, you people have a look. I don't want to have big, but anyhow, it came to me. I'll explain it. It's okay. 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 Now you tell me that my voice is audible or not.
Okay, madam.
Is it okay?
You are audible.
Okay,
Now it is
madam.
okay, fine?
Fine.
Okay, fine. Okay, sorry for the interruption. I tried to do something, but it was not working out. Okay. As I told you that there are three important treatment stages. That is, one is sedimentation with or without coagulation, and the second one is filtration, and the third one is chlorination. These three are major or main stages of treatment. Other than that, four auxiliary methods are there. That is aeration, softening, pre-chlorination, and activated carbon treatment. Why that is called auxiliary treatment? Because anyhow, this water treatment, why we have to do? I told you that it has to, the treatment has to be done for unpleasant taste, smell, and odor removal, and for removing of pathogenic bacteria, and for removing of turbidity and suspended impurities, and for regulating the pH, and also for hardness removal. For this purpose, we have to do the treatment means we have to do sedimentation with or without coagulation. By this process, we can remove that suspended impurities and turbidities. And also to some extent, pathogenic bacteria will be removed. This unpleasant taste, smell, and color, this parameter moreover, if we consider the water source for the public water supply, these three may not be there. So no need to do. In case sometime if it needs occasionally when the water characteristic changes due to some reason like season, some activities or some occasion it changes, means that time only we have to do the color, taste and odor removal. Otherwise, in general, turbidity will be there, suspended impurities will be there, pathogenic bacteria will be there, pH changes will be there, hardness will be there. These three or these four parameters compulsory we have to do. For this only, we have to follow sedimentation process with and without coagulation. And whatever the treatment we are doing, there will be an impurity of chemicals will be there that has to be removed by filtration process. And with that will be followed by disinfection process. Anyhow, in any substances, there will be a contamination. To arrest or to bring down into the zero level, we have to do disinfection process. Then why we have to do this auxiliary method means, sometime in some of the water sources may contain some of the organic substances like plant material or animal material that will be break down into small particles. Then those particles will be removed by other stage of process like coagulation or something like that through sedimentation process. In such a situation, we have to do aeration process. Aeration means what? We have to supply the oxygen or air into the water, which will break down in the complex organic substances into smaller size of particles or molecules. Then that will be degraded or decomposed by some other process, and that can be removed. That is the process of aeration. If there is no much organic substances in water, then no need to do this organic aeration process. Next one is softening. Softening means if the water contains a lot of hardness, then that hardness supposed to be removed. Based on the what are the chemicals we are using, for that we have to make the water to be soft. That process is called a softening. In general, people are using lime to make the softening process. If it is not, hardness is not there much, there is no increase or decrease of pH in alkalinity level, no need to do this softening process. We can directly go into the next process. And the next one is pre-chlorination process. What is meant by chlorination? I have told you. Anyone can tell me now? What is meant by chlorination?
Ma'am, passing chlorine gas to disinfect the water.
Okay, that is chlorination. Very good. What is meant by pre-chlorination? What could be the pre-chlorination?
Steps before chlorination?
It's for checking how much chlorine should be added, ma'am.
Checking the physical properties of water, ma'am. Like what is to be added? How is the water?
Oh, I have explained aeration and softening. If something is there, we have to do. If it is not there, no need to do. I tell you. Isn't it? I told you. Did you understand? Why we have to do aeration? Aeration is not must, but the major treatment stages like sedimentation, filtration, and chlorination, those three processes are very important. That is available in the previous page. It is not there in this particular slide which Durkesh shared. Okay, those three are must. They called major treatment stages. Sedimentation with and without coagulation, that I will explain in detail. Don't worry. Then followed by filtration, that followed by chlorination. These three are must do. But whatever the auxiliary method I told you, aeration, softening, pre-chlorination, activated carbon treatment, these four are not must, which depends upon the characteristics of water, which will be changed occasionally. Either by season, either by any occasion, either by some sort of festival or anything cost, then some of the characters will come and that may not be available for a long period, that will be changed. Something will go and something will not go like this. But major treatment compulsory do. These four, whenever it needs, we have to do, otherwise no need to do. So that's what aeration, when we have to do, when the large quantity of organic substances are present in water, that time we need to do. If it is not there, no need to do. Softening, if the water is little hardness, we are doing some alum treatment or something like that. If the pH will be reduced into alkaline, acidic level, then we wanted to bring down into alkaline level. So we have to add some lime, that is called a lime process or softening process. If the water pH is not at all coming down into acidic level, no need to do that process. Understand? Likewise, what is meant by pre-chlorination? Chlorination, you understood what is meant by chlorination. Pre-chlorination means what? Okay.
Dechlorination is maybe to nullify the initial bacterial growth.
Okay, very good. That is the correct answer. Pre-chlorination means, you know what is that? Pre-chlorination means in case sometime the water contain lot of my pathogens. Instead of doing at last disinfection process, previously, before doing all the treatment, you have to reduce that pollutant load or that pathogenic bacteria. That is called pre-chlorination. Okay, understood what I am saying?
Yes, ma'am.
Pre-chlorination, the sense when the pathogenic pollution load is more, that time before conducting all the treatment, we have to remove the pathogens level. Otherwise, what will happen? Other treatment stages will be affected high level to reduce the impact of this treatment techniques. We have to remove the pathogen in the previous or preliminary level itself. Or the first
How
or
are
second.
the pathogens removed?
When we are adding some of the chlorine compound, like in the form of chlorine dioxide.
Chlorine only.
No, chlorine only. That is called pre-chlorination only, name of the process itself.
Okay, ma'am.
Okay. So we have, that's what I pre-chlorination in the sense pre means earlier, before. When we are doing pre-chlorination, if the water is contaminated too much or the pathogenic or bacteria or microorganism load is more in that water, we have to reduce the level to some extent. And also we have to do the same process at the end of the process.
Okay, ma'am. During rainy season, it must be more, no, ma'am?
Yeah, yes. If it is more, we have to do the pre-chlorination process. Understand? Why we have to do preliminarily? Otherwise, which affect the other treatment techniques or stages. If we do it also, again, we have to do the same at the end of the process.
Okay, ma'am.
Understood? Clear? Otherwise, what will happen? This microorganism will be sitting on the coagulation tank, sedimentation tank, clarification tank, or filtration unit. Anywhere it will be affected. So to reduce that problem, we have to do the pre-chlorination. If it is not more, the pathogenic organism is not more, no need to do the pre-chlorination. Understood? That's what these techniques are called auxiliary methods. And the fourth technique is called activated carbon treatment. Activated carbon means what? Why we have to do activated carbon treatment?
Activated carbon to remove the smell, ma'am.
Okay.
Foul smell.
Okay.
And any unwanted organic carbon, ma'am.
Okay. Yeah, what is meant by activated carbon? Nubia, Asha?
I think it is for removing contaminants, ma'am.
We are doing treatment technology only, no? So it will remove the contaminant only. All the stages, one or other.
Filter.
I have told about activated carbon and activated carbon usage. Any one of you can explain? Nubia, Asha?
Ma'am, activated carbon, ma'am, it's like purification, used in purification process only, madam. Like
Okay.
water, odor removal.
That's why, okay, yes, correct. You and Durgesh answered to some extent. Okay, fine. I will tell you, activate carbon means what? You know what is meant by carbon. Okay. With steam or some chemical, the carbon is supposed to be activated to improve or increase the pore size and the pore volume in the carbon. That's what that carbon is called, activated carbon.
So that can absorb more, ma'am.
Now you tell me. I mentioned your name also.
Yes, ma'am. Yeah, I was remembering.
Okay, very good. Remember means it is use of teaching. If you forget means it is a waste of energy.
Yes, I was trying to recollect, and that's why I did not respond.
Okay, no problem. Okay, this activated carbon, which has the capability of absorbing capability, not absorption capability. What will happen when we are putting this activated carbon into the water? or you are pouring the water into the activated carbon column, what will happen? Whatever the unwanted particles, even the coloring matter, odor matter, everything will be absorbed by this activated carbon. Clear? So the color also will be removed and odor also will be removed. Mostly, in most of the things, people are using this activated carbon for removal of color in industrial level. Along with that, the odor also will go away. And some of the particles which are more than 4 size of the activated carbon, that also will be absorbed by this activated carbon. As I told you earlier, in many times in the classes, this activated carbon only earlier days in water filter people have used. You would have seen some cylindrical container of water filter, bottom one cylinder, top one cylinder, one tap will be attached. At the top, there was a 2 white color column was there. Could you remember?
Yes, ma'am.
Yes, ma'am.
And that inside that column, activated carbon only is available.
Yes, ma'am.
Okay. So this activated carbon, why we have to use? If the color of water and if the water is colored or what is that, water is there, we have to use this activated carbon to remove such a matter. If it is not there, we don't need to do this activated carbon treatment. Understood? So these four methods are called auxiliary method, because if the particular characteristics of water is available, then only we can follow. Otherwise, we have to follow. Otherwise, no need to follow such a techniques for treatment process. Is it clear?
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
Okay, then where is that slide? You people open the treatment stages. Now activated carbon he is sending. Very good. I know you people just have a look. Clear?
Yes, ma'am.
Okay, then you see that the diagram which has been shared by Durkesh. That diagram is looking like very bad, but the technique is very good. It is very, very important question in exam point of view. Till now, whatever I have spoken about this lesson is very important. From this lesson, 1 or 2 questions will come. One question must, and they will ask that entire lesson as a question. What are the different stages of water treatment? And sometimes they will ask write about the screening. Sometimes they will ask about the clarifier. One exam in 1 or 2 years they have asked.
Screening question has been asked mostly.
Which one? Clarifier?
No, screening, ma'am. Screening.
Yeah, screening, clarifier. Sometimes coagulation, coagulator, everything. It depends. Okay. So this is one.
You told to remind about clarifiers, ma'am, during class.
Now I will tell. Now only we are entering into the treatment stage. Now please allow me. When our class will be over by 2 o'clock. Let me finish this lesson.
Yes.
Okay.
Okay, ma'am.
You please look at that picture which has been shared by him. Please open it.
It's on page number
33.
also,
Page
ma'am.
33 in textbook.
Yes. We have shared. No, I draw already on the board, but I could not focus. I don't know, some problem I have. I could not rectify.
Durgesh, share it again for others.
Oh,
1
stop.
second.
Yeah.
Fine.
You're sharing.
I will attention.
Please fast, little fast. Okay. This
Yeah,
treatment, water treatment works not only here, there, everywhere.
Is it visible, ma'am, now?
Yes, it is.
Yes.
It is. You just to zoom it and see each and every session. The first section, you could see one diagram is there. No, the diagram you have. In that diagram, first stage is raw water channel. Raw water channel in the sense, we have studied about the intake works. Do you remember? From the intake works, the water is entered into the screen. Screen means what? Now I may explain about the screening. You please listen me carefully. The screening is a process which is being done for the removal of large sized impurities in water. That may be in the form of trees, debris, animals, branches of trees, bushes, or part of human body, part of animal body, whatever it may be. Okay. These screens are provided usually in front of pump or intake works. That intake work or pump both are same. There are different types of screens are available. One is coarse screen, another one is fine screen, which are classified based on the pore size of the screen. Coarse screens, which is nothing but a parallel iron rod, which is placed 2 to 10 centimeter distance from center to center. They may be placed vertically at or sometimes which make an angle with the horizontal place. And these kind of screens usually used to remove the largest size of particle, sometimes which remove the big floating bodies, human bodies, animal bodies, and branches of trees and plants. And those things are removed by this coarse screen. These coarse screens are usually kept at 40 to 60 degree inclined with the horizontal plane. And this will be removed only the large sized particles. Okay, understood? And the next screening is fine screen. Fine screen means which is nothing but very fine wire or perforated metal sheets with the opening of less than 1 centimeter material will be used for this. This will be removed the fine particles like very small suspended particles like the things will be removed. Usually these fine screens are not using at the immediate point of intake pipe or pump. They are using very big or medium size screen of coarse size only, because small particles will go and clog this screen, then it will not be often clean it up. Because of that reason only, fine screens are not followed in many places in public water supply. Only coarse screens people are using. Instead of using this kind of big rod, they are using small wire with a gap of, instead of 2 to 10 centimeter, from 2 to 4-5 centimeter gap, people started using. But they have inclined with the 40 to 60 degrees centigrade. Whatever the bigger particles are coming, it will be removed there itself. This process is called screening. Understood?
Ma'am, can we tell them bar screens also, ma'am?
Yeah, that where the time will come, I will tell, because here it is not required. We will do that bar screen and question where you wanted to separate the sludge material from the sewage or sewage treatment process. There we have to use bar screen. Bar screen it is nothing but they are using the same kind of iron rod, little bigger than this. The core size will be little smaller. They are also providing that vertical rod with incline 32 instead of 40 to 60 degree. They are using 30 to 50 degree inclination to the horizontal. They are separating the fine particles than this kind of bigger particles. Do you understand? Do you understand?
Okay, ma'am.
Okay. So this is about the screening. That is the first stage of treatment. And the second one is after screening, because in the screen very big particles only removed. Big particles, we can say big substances can be removed. Then small settleable, floatable things will be coming after screening. Those particles will be removed by sedimentation process. Sedimentation process means what? Which is nothing but, you can imagine that some of the particles are suspension in water. They are little heavier than water. If it is less heavier than water, it will be floating and going. Some of the particles are heavier than water. Because of turbulence of water or velocity of water or flowing of water, those particles cannot be settled down. It will be in suspension in water. Those particles will be settled down by sedimentation process. They are when the velocity or the turbulence of water will be reduced, or when the water is in still condition, that time it takes place. That process is called a sedimentation process, or otherwise it is called a settling process also. The process where it takes place for sedimentation or settling, that is called sedimentation tank or settling tank. This process, very good. What is this? It is a coarse screen. Okay.
Yeah, my screening.
Okay, fine. But in this we cannot. Yeah.
Then this is 30 degrees to 40 degrees.
Yeah, that is called a bar degree. What she asked, no, like that.
Okay.
Okay. About sedimentation process we are taking. The time theoretically required for the completion of sedimentation process or any process in water treatment technology, that is called detention time. Did you get my point? That is called detention time. The detention time is varied from process to process, especially for this aeration, sedimentation process. It is varied from 4 to 5 hours. Okay. What are the factors which affects the sedimentation process? That it depends, or the efficiency of the sedimentation process depends upon size of the particle, shape of the particle, the specific gravity of the particle, velocity of water flow, and viscosity of water. These are all the factors will be influencing on this sedimentation process. That is the second stage of water treatment. In sedimentation process, people are settled out the particle which are all heavier than the water that will be deposited or sedimented or settled at the bottom when the water is in still condition. There will not be any velocity, there will not be any turbulence. That process is called sedimentation. Is it clear?
Yeah.
Okay.
Yes,
In some cases, after this preliminary settling or sedimentation process, some of the particle will be less dense than the water molecule. I told you, heavier than the water molecule.
Ma'am, this is after screening, no?
Yes, and the sequence only I am telling, which I am going to tell, it is not there in your book. Okay.
Yeah, ma'am.
Okay.
This
And
is preliminary settling tank is relevant, that is sedimentation.
settling, sedimentation, both are same only.
Okay. Yeah.
Okay. So after preliminary sedimentation process, the water contained, the particle which are less dense than water, that will be suspended in form in water. They may be colloidal particle that in the form of organic and inorganic substances that will be coming out along the water. Then we have to do the aeration process. Aeration is not must, but first screening and the preliminary settling process is essential. This aeration process, when we have to carry out? I told you 50 minutes.
When there is large number of organic
substance are present in water, then we have to do the aeration process to convert the complex organic substances into manageable form. Then only this aeration process is required. If it is not there, then no need to do this aeration process. Understand? Sequentially, you follow me, then only it is useful. And the third process is, second stage is chemical feed. Now we have removed only the particles which are all heavier than the water. Now particles which are lesser than the water also we have to remove. For that, we have to do the coagulation process. Coagulation process means what? We have to add some of the chemicals into the water. That chemicals what will do? Which will go and attack the particles which are all present in the water. That is very minute, fine particle. They are all called colloidal particles. Those colloidal particles will be aggregate their size with this chemical. Then their size slowly became a bigger one. After becoming bigger one, slowly it is settled down at the bottom. This is the process. The chemical which are all using for this process is called coagulant. The process which we are carrying out with the coagulant is called coagulation. So after adding this chemical into the water, we have to mix properly or agilently we have to mix the chemicals with water. After mixing, the chemical which reacted with the particle that makes some precipitate that is called flag, FLOC, flag. The formation of or the process of forming flag is called flagellation. Okay. So these are all the sequence of process will be taken place in a same container sequentially. For this, what are the chemical can be used for coagulation process? What are the chemical? Have you heard anywhere about that coagulation process?
Yes, ma'am.
Yes, ma'am.
Okay, then no problem. So the coagulant generally used for this water treatment is alum. Alum means aluminum sulfate. And some of the iron salt like ferrous sulfate, ferric sulfate, perchlorate, and chlorinated copper, these are all other salts also can be used. By adding the coagulant, a flag is produced. Flag means what? Flag means it is very wonderfully defined in your book. That is, flag means which is nothing but a gelatinous precipitate produced by adding of some of the chemical that is called coagulant into the turbid water. Actually, some people may have this alum at home. Any one of you have?
Yes, ma'am. Yes.
Okay. Okay. If you have, means you do one thing. You take some wastewater from the sewage water. Anyway, when you are going out here and there, you take it in one small cup or something. You bring that water and add very little bit of alum into that water. You mix well and leave it for 5 minutes. Then how the things are happening, if anyone can take the photograph, take it and send to me also, send to others also. You look at that particle, how it is reacting, how it is aggregating from smaller to bigger one, you have a look. Then you just observe that how the precipitate is forming and how it is settling. It will not look like a complete solid precipitate. That's what they have defined it as a gelatinous precipitate, which is looking very nice, wonderfully. You can observe nicely. This is the entire process of coagulation and flagellation. What is this? People, some people are interested, you know. Don't disturb others, please.
Durgesh, from your phone only that voice.
My God, he's taking photograph again. Okay, did you understand what is meant by this coagulation and flagellation?
Yes, ma'am.
Okay,
Yeah,
we are going to see separate coagulation and flagellation unit also, and on the sedimentation also we have separate unit. There we will study what
Ma'am,
is.
do you have simpler diagrams for this?
Yes, yes.
We can understand and draw.
That's what I tried to make it on the board. No, I got ready also. I have drawn the diagram also for the different stages of treatment in the half-an-hour break. If
you take those photos and send it to Durgesh, he will put it on this, and then you can explain.
Now this I have to draw.
Okay.
Actually, that different stages of water treatment I have drawn already. That I could not. If I switch on my camera, my this what mic will off. If I switch on a mic, camera will off. I don't know what kind of problem it has.
And better use a laptop, ma'am. It will come.
My laptop has fallen. Motherboard has gone.
Ayo.
That's what I am worrying now. Okay, did you understand what is meant by coagulation, flagellation?
Yes, ma'am.
Okay, this is very important. It is very, very important question. Okay. Then when we are using this alum, this is very important point in general knowledge point of view and also in examination point of view. When you are using alum for this purpose as a coagulant, the pH of water will be increased. Why it is increased? Alum means I said it is aluminum sulfate. When you are putting aluminum sulfate into water, what will happen? You people use your general. Alum means aluminum sulfate. When we are adding aluminum sulfate into the water, what will happen? I told you that if you are adding
start settling
the
down.
impurities, ma'am.
Impurities start settling down.
Coagulation.
Okay. Then these are all I said. I asked the question.
Reduce the pH.
Remove the suspended particles, ma'am, whatever is there, it attracts it.
No, somebody said reduce the pH. Why it is reduce the pH?
It is in acidic nature.
What is acidic nature? Which one is acidic nature?
Alum.
Okay, what acid is there? Correct only. Please answer to me further.
You precipitate something, madam. That is the coagulation in water.
Okay. Something you have answered, but unknowingly have answered. Okay, I'll tell you. Aluminum sulfate means sulfate is there now. Some chemistry people can easily grasp it. They are adding sulfate into the water. What will happen? Sulfuric acid will form, isn't it?
Yes,
ma'am.
Okay. Then what will happen? Whatever it may be, the water pH, this aluminum sulfate or aluminum sulfate will bring down the pH into acidic level because this aluminum sulfate gives the sulfuric acid compound in water.
Yes, madam.
Okay. So
Okay.
in such, but this alum is a very good coagulation agent to coagulate the particle nicely, which will remove almost 90 to 95% of colloidal particles from the water.
Yes,
Which
madam.
gives excellent result. Not only which removes the colloidal particle, which also remove the color and odor also from the water.
Okay.
Understood? This is a
Yes,
very excellent chemical in water treatment point of view. But only the problem is when you are adding this alum, which decreases the pH into acidic level. So we have to add a little lime to bring up the pH into the alkaline level. That is called a softening process, as I told you. Ferrous sulfate also can be used for the same process, but alum is little costlier than the ferrous sulfate. But this alum process, which is very fast and quicker settlement, which makes the heavier plug in industrial application and also domestic application. This is the best chemical for this particular coagulation process. And one more thing, this I have told you that some of the iron salt also can be used for the same process, like ferrous sulfate, ferric sulfate, ferric chloride, and chlorate of copper. But those chemical can be used only when the water pH is in alkaline line. Clear?
Alum is antiseptic also.
Yeah, it's antiseptic also. People earlier days used to use for their shaving purpose.
Yeah, that's what I'm saying.
Okay. Yes. It is very good chemical. You people try to do what I have told you. If you are having in the pharma powder or anything else, you take it and do it. Okay.
Okay, ma'am.
This coagulation in general, the people are doing in a two stage. One is, first we have to feed the chemical into the water. Then we have to mix the chemical with the water. Then we have to, the chemical means here the coagulant only. Then we have to follow the, allowed to follow the flagellation process. After flagellation, we have to leave the things for some time for proper settlement. After settlement, we have to filter it off that filtrate and the clear water. That process is called clarification. Is it clear?
Ma'am,
Yes,
can you
ma'am.
repeat again, ma'am?
Sure. Don't worry. That's what I told you. People, please follow me confused. If you break here and there, you cannot. You may miss out something. What did I say? You know that I told you that when you are using the alum, the water pH will be decreased to acidic level. To make it neutralize or bring down the alkaline line, we have to add a little lime. Okay, that this is called the neutralization process or softening process or liming process we can call. That chemicals when we are adding into the water, which makes a heavier plug and also which makes a quicker settlement. So it could be the better chemical for industrial as well as this kind of municipal operation for water treatment technology. Instead of alum, people can use this iron salt also in the form of ferrichloride, ferrous sulfate, ferric sulfate, and chlorinated copper, all those chemicals. But those chemicals can be used when the water pH is in alkaline level only. When it is in acidic condition, it cannot be used. And this coagulation process can be done, or generally it is being followed in two stages. The first stage is called adding and mixing of coagulant, which is called the coagulation process. And the second process is allowing to form the flag, that is called the flagellation process. And followed by flagellation. Flagellation means what? We are allowing to make the precipitate of the added chemical. After this precipitation, we have to separate the clear water and the precipitate. That process is called clarification. Clear now?
Yes.
So all this process we'll see now. Sedimentation with flagellation, how to do now. Flag means, as I told you, that it is a gelatinous precipitate, and this process is done by when we are adding the chemical into the water at the speed of around 90 centimeter speed. After a violently agitation, again the speed is reduced to 30 centimeter per second speed. Then the water is allowed to settle down at the bottom. This process is called flagellation. The process is taking place in a device which is called flagulator. The flagulator, which is nothing but a rectangular container, which has inlet, outlet, and drain wall. And there is an arrangement which will be giving the slow stirring of water by the pedals, which is being shown in the book. And the pedals are standing like a vertical line, and horizontally they have fixed with the stones that will be slowly rotating by the shaft or driven by motor. Then it is being maintained. What is that?
Somebody.
Can I mute this? You people cannot talk. That's what I'm keeping quiet.
Yes, ma'am.
Then what should I do? Disturbing. Involvementally, I have explained where I have stopped. Okay.
That's why we are muting, ma'am. Whenever we want to speak, we are unmuting it.
Okay, then do everyone do like that, please. All are in line or not?
Sorry, ma'am. It is.
So, yeah, everyone, please mute yourself. And when you want to talk,
Okay,
you please unmute yourself and talk, because it gives.
Following the same only, ma'am. Following the same.
Somebody is making noise, disturbing the sequence.
Some people are not muting, ma'am. So.
That's what I am requesting everyone. Please mute yourself. I think somebody gone.
Krishnamurthy, I think.
If you do like this, then I will block you. I am telling like this because others are getting disturbance, including me.
Madam, I already mute, madam. Sorry, madam.
Okay. Thank you. Fine. Thank you. Okay. So this where I have to be about mixing, I am saying, isn't it? Or flagulator. Yeah, flagellation where is being done? It is in a flagulator which is nothing but a rectangular container or tank, where it is provided with inlet, outlet, and a drain wall, and there is an arrangement for stirring of this water by rotating the pedals, which is mounted on a horizontal shaft, that is driven by the motor. You can see the figure which is being shared by Mr. Durkesh, or on your page number 34, figure number 42, 4.2. There, horizontal vertical lines are there. It is mounted on the horizontal the pedal. You could see this pedal will be controlled by the motor. It is slowly rotating. When it is rotated, this pedal is rotated in the container slowly at a RPM rate of 2 to 3. Then the water is getting mixed well. Then we have to reduce the speed into 30 centimeter per second level, which has to be leaved for 30 to 60 minutes retention period. When we are doing like this coagulation and flagellation process will be completed. Then the gelatinous precipitate will be deposited at the bottom. The clear water is standing at the top. Then next we have to separate that filtrate and water. So how we have to do? We have to allow this flagellation point or flag to settle at the bottom for some time. That is 30 to 60 minutes, I said. That period is called the retention period, I said. Then we have to take out the clear water from the top of the container and remove that filtrate at the bottom. That separation of this process is called clarification. In some of the exam, sometimes they have asked write about the clarification and clarifier. It is only 2-3 sentences you cannot write. So whatever I said, I include everything and write. Okay. In this clarification process, what will happen? Sometimes this clarifier can be the part of the coagulation processes or coagulation tank itself. And sometimes they are making separate unit at the end of the process, which depends upon the scale of operation. What is meant by this clarifier? Clarifier, which is nothing but a rectangular device or a rectangular container or basing like a flagulator and coagulator, where the horizontal velocity of the flow is maintained in such a very low level like 30 centimeter per minute. In an average, when we are feeding the water, that time it has to maintain at 90 centimeter per minute. Here the surface loading rate per square meter is around 40,000 liter to 60,000 liter, means you can say that the water, when we are allowing into the clarifier for clarification process, that should not be disturb the water. If you disturb the water,
Again, whatever the fog or precipitate form, it will be mixed and dissolved. To avoid that, the content of the clarifier should not be disturbed throughout the process. Okay. So here also in this clarifier, the people have designed with improper inlet and outlet, so that there will not be any disturbance formed for that settling zone or in the settling part of the clarifier. Here for this process, the detention period is varied from 1.5 hours to 2.5 hours. And whatever the sludge, that means that fog or precipitate, that has to be removed continuously from the clarifier by hydrostatic pressure into the nearby sewer, or if it is useful, means people are make use of that, they are making the bricks. The amount of sludge produced is comparatively small from the other process. The chemical feeding and mixing can also be taken place in the clarifier. So single unit can be behave like a flagulator, coagulator and a clarifier, which depends upon the loading of the pollutant as well as the kind of treatment what follow. This is about the sedimentation, flagellation and clarification. We have seen in one topic about all the three things. Each and every topic we will have separate unit. Sedimentation unit separate, flagellation unit separate, coagulant unit separate. For the clarification, there is no separate unit. Okay, clarification means this much only. So you people have to write right from the starting what I have explained about the coagulation, coagulant, flagellation, flagulated, clarification and a clarifier. Not right all. Understood? Then next, what is meant by filtration? Next, we are going to see about the filtration. You see the diagram. This is, I am talking about that chemical feed at the third point. Second point is chemical feed. Chemical feed, which is nothing but we are adding the coagulant. Then third point, we are doing the mixing of the chemical with water. And then fourth point, after mixing, we are leaving it for some time. That after pedaling everything, we are leaving for 30 to 60 minutes detention time in the flagellation. That is called conditioning. Then fifth point is clarifier. Fifth point is clarifier, where we are separating the water and fog. After clarification process, we are sending this water for the filtration process. There are two different types of filters. One is the rapid sand filter and another one is slow sand filter. These filters have been classified based on the rate of filtration process. And after that, it will go to the filter. Their fine screens will be there to filter it off. Then after filtration, the water is subjected to common water supply system to the public. Clear? This is the water treatment stage. Yes, okay, now we are in the filtration process. I think you would have understood screening, sedimentation, coagulation, flagellation, and clarification. Now we are in the state of filtration. What is meant by filtration?
Filtration is
filtration.
The impurities at different stages.
All the three are speaking. Who said what? Who can understand? One by one, you can talk.
Removing the impurities at different stages.
Okay. I am not talking about the asked about in water treatment. What is filtration? I am asking generally what is meant by filtration.
Separating water and impurities from each other, ma'am.
By using filters.
No one is making tea at home.
We are making, ma'am.
Then what you are doing after making tea?
Of solid impurities and liquid water.
Yeah, that means you are getting the clear solution from the turbid one, isn't it? Separation of impurities from the water, from the mix, we can say. So that the same technique here, we are adding the coagulant, coagulation, flagellation, clarification takes place. Clarification, which is nothing but the secondary settling process. That is normal settling only, the particles are separated out. There is a possibility of some of the particles may come along with the water, clear water. Those particles have to be separated out or filter it off by proper filtration media or filtration system. So that's what people are using this rapid sand filter and slow sand filter. But commercially, at a large scale level, rapid sand filter only people are using. For that is a filtration, the rapid sand filter, you have separate unit. There I will say what are the types of, what is meant by rapid sand filter, what are the types of filter, what are the material people are using for that filter. That is amazing unit. Really, you will be surprised if you are going through it. That much big information is available on this filtration media. Clear? So here the people are doing this process for separating that and further purification or removal of impurities from the water which is coming from the coagulation or flocculation process. Understood?
Filtration is done after coagulation, sedimentation, flocculation, and clarifies, no, ma'am. If still anything is left only, we'll do filtration. Or it is also a process.
No. Actually, clarification means what?
That is also
removal of flag from the water, clear water, isn't it?
Yes, ma'am.
When you are taking out the clear water from the top layer of the clarifier,
yes,
there is a possibility of small particle may come along with the water, no? When you are taking out. Why you are using tea filter? You leave the tea like that, it may settle down. No? To what we wanted to make it proper filtration, that's what you are doing, isn't it?
Yes, ma'am. Yes, ma'am.
The similar way, you are normally taking out that pure water from the top of the clarifier, which may get some other particle or flag particle also along with the water. To remove that, we have to do the filtration process. Clear? Okay. Now, so filtration means what is that is low sand, rapid sand filters are we will see in that particular unit. Now this is a general knowledge. Whatever I told you, and from your side, you people please tell me what are the chemicals in general people are using for this water treatment work. Then after filtration, once the filtration is over, you see your diagram.
Alum is a chemical, and chlorine, bromine, fluorine, all these are also used.
Very good. Common water supply is there, no? Before that, filter in between that two, we have to do the disinfection process. Disinfection means already I told you, no need to explain. At the same time, we have separate unit on disinfection also. That unit I will teach you very nicely. Don't worry. If you listen that class carefully, you can directly go and write the exam. Like that, I will explain that lesson because that is very important to learn in the life. In life, okay? So what are the chemicals? Generally, chemicals used for the water treatments is for coagulation, people are using aluminum sulfate, alum, and another iron salt like ferrous sulfate, ferric sulfate, ferric chloride, chlorinated ferrous sulfate, that is chlorinated copper, that is called sodium aluminate and sodium silicate. All these chemical names you people have to remember. Okay, it is not much; it is very few only. Then in generally, people are using some of the chemical for disinfection or purification process. There are two types of chlorine compound people are using. One is chlorine compound that is in the form of bleaching powder, chloramines, and free chlorine gas. And the second one is chlorine dioxide. Have you seen chlorine dioxide anyway?
No, ma'am.
No, ma'am.
No, that is very difficult to see. That's what I asked you. Forming also very difficult. It is very costly process. People are not following in general. When they are doing hydrochloric acid or bleaching powder effect, that compound will form. The lifetime of that compound is very less time at neutral pH, but that effectively do the job. That is true. Understand? I will explain when we are talking about the disinfection. And the chemical used to remove hardness. What are the chemical can be used? I told you that lime. Lime, I told you, soda ash also. Then zeolite compounds like aluminum, silica, and soda. These chemicals also can be used for remove the hardness. In your class practical, you will do the hardness removal also. When you people do, you please call me and tell what did you learn from that. because which day what practical you do, I may not know. So when you are doing this hardness removal, please give me a call. Understand?
Okay, ma'am.
Okay. And I would like to remind me that about rainwater. No one was telling me. In last class, when I was explaining about the dissolved oxygen, you please remind me about rainwater. I will explain little more. No one was reminded. Everyone forgot, including me. Actually, any one of you tasted the rainwater? Hurry, I'm asking any wrong question or what?
Tasted, ma'am, but it was in droplets, so couldn't understand what the taste was.
It is really tasty, no?
Yes, ma'am.
Okay. My God. My dear students, you are all from the 12th planet only.
We tasted, ma'am. It's like salty type.
Salty type. No, sir.
No,
Ma'am,
it's not
no,
salty.
it is not salt, ma'am.
It's very nice, just like
Nice actually.
hill water, ma'am.
Yes, yes. Have you observed at any time people was ready and roaming here and there to collect the rainwater while it was raining heavily? Anywhere have you seen? No, you are all in modern.
No,
Yes.
Yes, ma'am. And when you collect the rainwater, is very good for washing the clothes.
Okay, then. Any one of you cooked with rainwater?
No, ma'am.
No, ma'am.
My God, I'm not asking the wrong question. I'm asking very right question, very good question. I have done. I cooked with rainwater. I drank that rainwater. It is
You collected so much water and cooked with it, ma'am.
Yes, yes. Actually, in my mother's house, that is single floor building, one house, that terrace will be very clean. After rain, we have to leave the water for 5-10 minutes. If it rains for half an hour, 40 minutes continuously, very good rain means first few minutes we should not take that water because all the pollutant dust, everything will be, even acid mist is there also, acid rainfall. We have to leave the water for 10-15 minutes initially. Then after you have to keep some container from the, here we do not have that kind of system in city. Their individual independent house to drain that rainwater from that terrace, they used to provide some sort of pipe. Okay, from that pipe of waterfall, I used to collect. Even I used to collect that water. I used to keep more than 1 week, 10 days also. You try to cook in that water. You try to drink that water. That taste you won't get in life. Understand?
Okay.
That water is very, very tasty. If you make rice, if you make anything, make use of that water. The taste is not at all comparable. Even not only me, in many places I have observed in many villages, till late people are getting the container. They used to roam to get the rainwater. Why I have to say, in earlier days, chemistry people for the chemistry lab distilled water purpose, they used to get rainwater only. Make use of the rainwater, they get very good result than the whatever the distilled water they make by their own. Clear? The rainwater pH will be at 7 or 7.2, sometimes 6.5, 6.7, 6.8 like that. But according to the theory, it's supposed to be at 7, but it is little variation. The taste is excellent. You cannot marvelous. You cannot imagine it. Always the water is in chill condition. It is very chill. If you any time at the time
Yes,
of your
ma'am.
collection, at the time of collection to 1 week, 10 days also, that the chillness will be maintained and that flavor will be maintained, the taste will be maintained. And if you cook, it will be very nice. Understand? You people have the possibility, you try to do and let me know also. Aliya madam, have you not done in your earlier age, younger age? She's not there. She's not there in the class. Hello?
She's there, ma'am. Dalia, she's asking
There,
you.
ma'am.
Okay, okay. I think she
Yes,
didn't
ma'am.
listen. Okay, ma'am.
I can't
You can,
understand it. You're asking me.
ma'am,
Yes, ma'am.
in your younger age, in your childhood, in your place, no one was collecting this rainwater for cooking?
No, ma'am, not cooking, but my mother and me also use the rainwater for washing our clothes.
Washing
Many
your clothes. Yeah, that is
ma'am,
also good.
clothes.
Okay, you are in hereafter, if possible, collect and use that water for cooking. Just to share your experience with everyone of us, if possible, to collect the rainwater, because in city it is quite difficult to get. And also, clean water you may not get. You have to leave the rain for 15-20 minutes. Then it rains heavily, then only you can get the good water. That water is very clear, there will not be any particle, there will not be any dust, there will not nothing. It is transparent and little tinge color, greenish yellow tinge will be. But we can say, I told you, from some of the spring from the hill station, if you get means how the water could be, like that look it has. But it is very good. Okay, now these are all the chemicals. Whatever the chemicals I have mentioned, those chemicals still people are using for water purification and also for water treatment works. Now another question. You are telling about this chemical. How you could add the chemical into the water? Simply can we take something and put it in the water? That will work out. In large scale level. You just think about that entire Hyderabad water supply, how much it could be, how much water supposed to be treated, how they will treat. 1 kg, 10 kg of chemical, simply they add into the tank, they will mix and leave it, that work will be done. Hello? No. Then what they would have done? Okay. These chemical can be feed into the water by two ways. Either they can be used powdery form, or they can be used liquid form or in the solution form. Clear? So how they are feeding? First they are making the dry feeding. How they make the dry feeding? Dry feeding means the chemicals they form in the powdery form. That powders they have stored in one container, which is something like a cylindrical device. From then they have used to tooth and bead, and which is being controlled by helical screw. This is the common way people are generally used. From this device, the dry powder of coagulant, and already it is filled with the hopper, that is conical kind of device at the bottom. Then they are providing the small agitation by agitating device. The powder is slowly coming into the water tank. They have provided some sort of device which will prevent the chemical should not form any sort of lumps or stabilization. Clear? For easy example, I will tell you. Any one of you went to that any rice flour or this chili powder making? How they are making? Kirni, anyone went? When they are making the powder, they will give one small agitation. From that agitation, they are maintaining the flow. If they are making like that, inside there will not be any formation or lump. To avoid that, they will do like this. Here, there are
Ma'am, while we grind also something, we keep shaking this thing container so that it gets grounded properly.
Yeah,
maybe
that we are giving agitation, we are giving. That is, it is not flowing. I am talking about the flowing system. Yeah, when we are making powder also to avoid the lumps and here something is there, so often we have to open and we have to mix it, grind it. That is okay. But there will not be any flow, it is stagnant, but it is rotating. Here, all the things are happening. There is a flow from one container, the powder form will fall, and the powder is going into the another container where the water is. This is a continuous process. The water is also continuously coming. The powder is also continuously going, and after adding this water continuously going into the mixing tank where it is mixed. Clear? For that, they are providing one small device that is called a helical screw. When it is rotating like this, the powder is at a uniform or constant speed according to the water content, it will come and flow into the water. And another important, there are two methods. This is for solid feeding of chemicals into the water. And at the bottom, they provide the hopper, where they are providing the revolving helical screw, or sometimes they provide the tooth and screw that I have explained in the class last time. For what I have explained, I don't, yeah, for separation of this particulate matter from the flue gases. When I have explained, I have told you this. And the tooth and wheel also they have to fix. And in this particular system, already the known volume of or concentration of solution of chemical prepared and stored. And whatever how much quantity, whatever the concentration and how much quantity of the solution they wanted to for that known quantity of water treatment, it will be proportionally taken from the chemical tank into the water. That is, they are being done by two methods, that is conical plug and floating method, and another one is wet feeding by adjustable weir. These are all the mechanical method. There is no energy is required. There is no only human being attention is required. Automatically, the system will work without giving any extra energy. But a mechanical automated system, this is how they are feeding. You people can look at your book on the page number 37, figure number 4.5. Take it very fast. Already it is 2. Rajita madam will give a call or she will be terminated the meeting. It will fast. Okay, otherwise I will explain. Can I?
Okay, ma'am.
You open it. At the bottom there are 2 tanks. One is the raw water channel, another one is floating channel. This method is called the wet feeding by conical plug and floating method. Just above the middle one tank is there. The chemical is coming from outside, which is coming into the feeding tank, which is going into the raw water channel, that is going into the floating channel. All this operation will be controlled by the top line. There are pulley, rod, tooth and wheel. You understand? Now, the chemical is coming from the outside. The water is coming from the right side. If it is rotating, the chemical is feeding. If the quantity is more, that will be pulling up. That time the water will fall. If the water will fall, that will be rise up, then chemical will fall. Like this, the situation will be continued till the quantity of water is being totally treated. Again, I will tell you, the flow of raw water increases. Here the conical plug, wet and the floating chamber and a mixing channel, all 3 are interconnected. If the raw water flow is increases, the float in the floating chamber little rise, then the pulley rotates in the same direction. Because of the same direction, the conical plug is little lifted. When it is lifted, what will happen? The more coagulant solution is permitted, you will fall into the mixing channel. When it is happening, when the then it is the mixing is taking place. For example, when the flow of water decreases, then the reverse thing is happening. That means the constant head can automatically control dosage of coagulant into the water. This process is happening automatically. There is no people or human being or technique is required to control operation of the system. Clear? No. You have to read. You have to find out. Then only you can. Hello?
Yes, ma'am.
Hello? Okay.
Yes, ma'am.
Similarly, this wet feeding by adjustable wire and float. Here also the feeding tank will be there. Then raw water channel will be there. Floating channel will be there. Only the condition is the string is operating here. The string is up and down. The adjustable wire will go up and down. If it is more, it goes up. If it is less, it comes down. Accordingly, the floating channel float is there. The floater will be moving up and down. The quantity will be maintained in the raw water channel and in the mixing channel. That is the process taking place. Like that, the chemical solution. Chemical is added in the form of solution into the water tank for the water treatment, and the powdery form through that tooth and wheel and the chemical screw. These 2 methods people are following the powdery form of chemical for this water treatment. And in both the case, the water is stored in a water container. This chemical is stored in a separate container. Powder means we have to use the tooth and wheel and conical screw. Liquid means we have to follow this conical plug and floating metal. In both the case, floating channel or float only will be useful for controlling the flow of water. The feeding tank and the chemical feeding tank in both the case also will be controlled by pulley kind of thing. Here also floating channel will be there that only arrests the flow of chemical into the water tank. Proportionally, which will be working according to the movement of water and the level of water increases and decreases automatically. Anyhow, this process is also both the process are continuous process. That's what at large scale level, following by this the continuous process, they can meet the demand of water. Is it clear? No, this you have to read, then only you can understand. At least that's what actually next time what I can do. You people tell to your senior or juniors, next batch you people should have only offline class, online classes it is useless. You have to say. Even whatever I'm speaking, it will be recorded, but I don't mind. And then on page number 38, some problems are there. That is for your knowledge only. People just to go through it and think. Understand?
Yes, ma'am.
Okay, the next class is on aeration. The topic will be started from this lesson only. We will see it on tomorrow or day after tomorrow, whenever. Before 1 hour, we will inform you. Thanks to every one of you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you. Thanks to every one of you. Okay,
Thank you,
any
ma'am.
doubts? Thank you. Do you have any doubt means you can ask me immediately. The class will be ended now. If you have any doubt, anything, what do you want to clarify, means please ask me. Hello.
No, ma'am. Once we read it, then we will have doubts.
Okay, then you ask me. Okay, thanks to everyone. Okay, bye.
Okay, ma'am. Thank you. Bye.
Thank you, bye.
Bye, ma'am.